Hey there, STEM kids. Sorry, you're not kids. Hey there, STEM students. This is Miss Ruark. I told you that I would put the answers and solutions to the quantum numbers worksheet that we were working on in class, and so this is it. All right, now remember, I only have 15 minutes. It should take less than that, but if I rush, rewind, watch again, ask questions when you come into class, and write down what your questions are so that you can tell me what those are and I can clarify them. Okay, so explain why the following ground state electron configurations are not possible. Remember, if it's a ground state electron, the s orbital can only hold 2, the p can only hold 6, the d can only hold 10, and the f can only hold 14. Also, if it's a ground state electron, that means it has to have the lowest energy possible. And in order to have the lowest energy possible, you have to fill in the first ones, the lowest energy first, right? So 1s2, 2s3 can't be possible because it has a 3 there. Bad. Sad face. Right? Okay, 1s2, 2s2, we're good so far. 2p3, 3s6. Okay, first, there's 6 here. You can't have 6 here, you can only have 2. Second, you can't fill up the 3s until you fill up the 3p or the 2p first. Okay? Letter C, 1s2, 2s2, 2p7. The most you can have in the 2p's is 6. 3s2, 3p8. Again, the most you can have is 6. All right, 1s2, 2s2, 2p6, 3s2, 3p1, 4s2, 3d14. Okay, first you can't have 14, you can only have 10, but you got to fill this one up first. There's supposed to be 6 electrons there and there's only 1, so those won't work. Okay, give 2 examples of A, an atom with a half-filled subshell. That was cute. Subshell. Okay, so a half-filled subshell. What that means is, let's say if we were looking at lithium. Okay, lithium's electron configuration would be 1s2, 2s1. If we were to show the orbital notation for that, you would see it as, here's your 1s, and here's your 2s. All right, this would be considered a half-filled shell because it only has half of what it can hold, right? So lithium, there you go, is a good example of a half-filled subshell. All right, what else have we got? Let's see. What about nitrogen? Nitrogen, 1s2, 2s2, 2p3. All right, if we were to do the orbital notation for that, we'd have 1s with 2, 2s with 2, and then your 2p would have 1 in each, right? Half filled. There you go. Yes, very easy. All right, an atom with a completely filled outer shell. Well, if you remember anything about what we talked about with valence electrons, you could put any of your noble gases here and those would fit because neon has a full outer shell. Helium has a full outer shell. Xenon, etc., etc. All right. An atom with its outer electrons occupying a half-filled subshell and a filled subshell. All right, so on this one, look here. We already showed one. Outer electrons, 2 and 2, full subshell, half-filled subshell. Oh, yeah. So nitrogen would work. And guess what? If you wanted to take the easy way out, you could say, well, if nitrogen's that way, then guess what? So is everything else below it. So phosphorus would work, and so would arsenic, and so, yeah, you get the point. Okay. All right, number 9. Place the following orbitals in order of increasing energy. So we're going from lowest energy to highest energy. Of course, we're going to start with 1s. That's the lowest. Oops, not 2. We don't want to put 2 there. Okay, next would be 2s. No. 2p. No. 3s. Oh, 3s. 3s is next. Okay, after 3s is 3p. We have a winner. 3p. Yay! All right, after 3p is 4s. Look, there's 4s. After 4s is 3d. Yay! All right, after 3d is 4p. Nope. How about 5s? Nope. How about, what comes after that? 4d. Nope. 5p. Yes, here's 5p. All right, after 5p comes 6s. After 6s comes 4f. After 4f comes 5d. And then what's left over? 7s. All right. Number 10. What are the possible m sub L values for the following types of orbitals? So for For the S, it can only be 0. Remember, your M sub L value is going to be from negative L to L, positive L. And if L is 0, it can only be 0. All right, for P, it can be negative 1, 0, or positive 1. For D, it can be negative 2, negative 1, 0, positive 1, and positive 2. And then for F, negative 3, negative 2, negative 1, 0, positive 1, positive 2, and positive 3. Okay, number 11. How many possible orbitals are there for N equals 4? All right, so in the fourth energy level, we have S, we have P, we have D, and we have F. Yes. The S sublevel has 1 orbital, the P has 3, the D has 5, and the F has 7. So if we add all those up, what do we get? I don't know. I was asking you. Okay. 4 plus 5 is 9. 9 plus 7 is 16. So 16, right? 16 orbitals. And how many total electrons did we say could fit in those orbitals? 32 electrons. So all you had to do is take half. Oh! Okay, number 12. How many electrons can inhabit all of the N equals 4 orbitals? Oh, look, we just answered that question. Yay! Okay, moving on. Okay, this is probably where your head started to spin. So number 13, fill in the blanks with the correct response. The number of orbitals with quantum numbers 3, N equals 3, L equals 2, M sub L equals 0 is 2. We can have 2 of them like that. One of them with a positive 1/2 and one with a negative 1/2. It could be either one, right? Right. Okay, the subshell with the quantum numbers 4 and 2, N equals 4, L equals 2, is going to be subshell 4D. Right? Right. Okay, the M sub L values for a D orbital could be negative 2, negative 1, 0, positive 1, positive 2. Letter D, the allowed values of L for the shell with N equals 2. So if N is equal to 2, the second energy level, we can have an S and a P, right? So the values would be 0 and 1, S and P. The allowed values for L for a shell with N equals 4. So in N equals 4, we can have S, P, D, and F. So we can have 0, 1, 2, or 3. Okay, the number of orbitals in a shell with N equals 3. So in N equals 3, energy level 3, we can have S, we can have P, we can have D. S can have 1 electron, 1 orbital, P has 3, and D has 5. Don't agree with me. It's not 7, it's 5. All right, so 1 plus 3 is 4, plus 5 is 9. So 9 total orbitals. How many electrons? 18. All right, the number of orbitals, oh, we're getting specific here. The third energy level, and L is equal to 1. So in the P sublevel, how many orbitals with the 3P? And there are 3 orbitals. What's the maximum number of electrons? That would be 6. Okay, maximum number of electrons with quantum numbers 3 and 2. So anything that's in 3D. How many total electrons can we fit in the 3D sublevel? 10. All right, now letter I. When N equals 2, L can be what? So in the second energy level, L can be S or it can be P. So L would be 0 or it would be 1. All right, remember, if you're coming across these, you're like, what? Just put a question next to them, okay? Fill in the blanks. Again, J, when N is equal to 2, the possible values for M sub L. When N is equal to 2, you can have S or P sublevels. S is 0, P is 1. So the possible values for M sub L are anywhere from negative to positive. So negative 1, 0, positive 1. The number of electrons with N equals 4, L equals 1, so 4P. Total number of electrons would be 6. The subshell with N equals 3 and L equals 1, so 3P is designated as the 3P subshell. All right, the lowest value for N for which a D subshell can occur. A D subshell does not occur until the third energy level. All All right, number 14, which set of quantum numbers are unacceptable? So which ones do not fit? Okay, so this says that it's 3 negative. We can't have a -2. That one doesn't work. All right, 2D. We can't have a 2D. That doesn't work. All right, 6D. Can we have a 6D? Can we have a 6D? Yes. All right, -2 and +1/2. Woo! That one works, right? Yay, happy face. All right. Almost done. Write the values for the quantum numbers for the bold electron in the following diagrams. So this is the 3p orbitals. Number for p, we do -1, 0, -1, 0, +1. So your quantum numbers for letter A should be 3, 1, third energy level, p sublevel, +1/2, or +1/2, sorry, +1, +1/2. All right, for letter B, fifth energy level, S sublevel is 0. Your orientation is 0, and it's a -1/2. On C, 4, because it's the fourth energy level. D would be 2. Remember, this is a -2, -1, 0, +1, +2. So it's going to be a -2, and it's a -1/2 because it's going down. All right, and then for 3D, 3, 2 for the D, -2, -1, 0, 1, 2. It's going to be 0 for your third and +1/2 for your fourth. All right, I think that's it. Woo! Okay, I hope you did well. See you in class.